Hi, welcome to you in another interesting video, which is actually a continuation of this series of questions. As you see that the two springs are in series connected, and we have seen in this video that how the extension is produced in every individual spring and how the force is transmitted in the spring. But now what will happen if we attach the two springs in parallel? Now what force will cause extension? We will see it from the Hooke's law, and in another method, I will explain you by finding out the equivalent spring constant. So stick to the video till the last second. And for example, if this is a 2 kilograms of the mass as stated in the question, so it means that, dear students, you know that this will be the force of gravity that will be downward. We have find out its value in a previous video that was equals to, if we take the value of G10, so that is a 20 Newton. Now this 20 Newton, in the previous case we have seen that this 20 Newton was equally applied in both the springs. That's why we have calculated here, we have put the same value. But now this time, this 20 Newton, just imagine if I show you a free body diagram. So as you have attached the as you have attached the block, right, it will certainly extend the spring, okay, and it will elongate. Now we have to find out this value, that is extension. Now if we represent this thing in a free body diagram, let us see. This is, let's say, the mass block, which is the 20, like a 2 kg, okay, and you know that the force that is exerted downward is how much, that is 20 Newton. Okay, this is a force of gravity. Now since this object right now is in equilibrium, right, which means that sum of all forces exerted on this block is equal to 0, which means that if the 20 Newton is applied downward, that must be equals to 20 Newton upward. So the applied force upward, that is the total force upward, is also 20 Newton, which is the sum of the two spring forces, right? So this is the total spring force. Okay. Now it should be, so it means that this 20 Newton is equally distributed. Dear students, this will be 10 Newton and it will be also 10 Newton. Now the spring force 10 Newton is, with the help of that we can find out the extension in every spring. And by the way, you don't think so that the extension value is same. Okay, so if we apply the Hooke's law, so Hooke's law, which states that spring force, and I'm writing the magnitude, right, k delta y, I'm writing delta y because elongation is on y-axis. Now, so spring constant is 200 Newton per meter. Okay. So now if I want to find out the delta y in one spring, so that would be the force in that spring divided by the value of k, and that is how much the spring force is equals to 20 Newton. Okay, by the way, it's not 20, it is 10 Newton, as I told you, divided by the spring constant is 200 Newton per meter. So the answer will be 0.05 meter. Okay, now just quickly compare this answer with the previous question answer, which was a zero point 0.1 meter. You see that? And why it was zero point 0.1? Because the force applied was 20 Newton. It was not distributing into the two equal forces. Okay, all right. But in this question, since the both springs in elongate in the same pattern, okay, so we see that this extension is same. And there's another reason that I will explain you the second method, so please don't skip the video. So this is 0.05 meter is the right answer, so both will extend by 0.05, so that's why the total elongation will be the same one, right, this one. Okay, now, so now in a method 2, we will first of all find the equivalent spring constant, and from here you will get a reason that why the extension is smaller than the previous question, right? Now when the two springs are connected in parallel, so their equivalent is always equals to the simple sum of their spring constants, right? So now, since it is, what is a value, 200, so 200 plus 200 is equals to 400 Newton per meter. Now, dear students, I already told you in a previous video that if the spring constant is a larger value, it means that the spring is actually more stiff. It represents the more stiffness of the spring, which means that the spring has become hard. The equivalent spring constant is a larger means now it is difficult to elongate the system of these two springs. That's why you need to apply a larger force, okay, to produce the same extension. All right, so this 20 newton, now this time the weight will produce the less extension. So if you want to find out what is the extension of the system, so that is the spring force and divided by the equivalent spring constant, and you know the spring force is equals to the weight mg we have just seen from the free body diagram over k equivalent. So let's put the value, and the weight is 20 over spring constant is 400. So what is the answer? 0.05 meter. So the same answer which I have shown you here. So that is how the we calculate the extension when the two springs are connected parallel.